Ready for the exam?
Yeah, I think so. I feel pretty good about it.
I was until I started doing this homework.
Huh?
I said I was until I started doing this homework.
Oh, yeah. I had a little bit of trouble on the quiz for this weekend's homework.
Oh.
7. And then I took it again, and it was just because I didn't read through the questions all the way. I was glancing, which I shouldn't do. I know this.
I know. I did the same thing.
I took it again and got like a 90, so I felt pretty good about it after.
I got a D the first time, and I was like, oh boy.
I know. I was like, oh, what did I do wrong?
Let me read this again.
Yeah, and then I organized all my notes for everything, so like okay. I have it. Yeah.
Awesome.
So that is good.
Good. Okay. All right. So tonight we just have to take the quiz together.
Okay.
Yeah. So mine's open when you guys are ready.
Right. I'm getting it up
there.
I have like a million tabs open because I was doing like other homework at the same time.
Standard deviation can never be negative, right?
That's true.
Okay.
Yes, it should only equal it can only equal 0 or 1.
Okay.
Okay, starting lesson 8 group meeting quiz.
Yeah. All right, I'm here as well.
Okay, wait a minute. That we don't need.
I'm sorry.
That.
Okay. 31 questions. My goodness.
I know. It's all of the homework questions though.
Oh, good.
I think. Pretty sure. Yes, it is. Sorry.
Okay.
Hold on just a minute. I'm pulling it up. Okay, we're going to put that down there. Okay, we've got that. And there's everybody's pictures back.
Are we all on the quiz?
Yes.
Yes.
Okay. All right. So question, we'll start with 2 because 1 is just are you by yourself or are you with your team or whatever?
I met with my group.
Yes.
Okay, true. All righty. There we go.
Okay. Which of the following variables is /are categorical?
Very good.
I put a random selected brand.
Yes.
Yeah.
It's the last 2, right?
Age and years of randomly selected vehicle.
Sorry, no. It's B.
It's just B.
Okay.
Okay.
Number 3, I guessed on. So
the mean IQ test in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements are true?
So I put that 100 is the parameter. But even then I was still unsure about it. So then if you go to the homework and look up or have it show the answers or whatever, it says, where did it go? Oh, that a parameter is a true number, but usually unknown, that describes the population.
Yeah.
So that's why I was unsure after I put that. And then a statistic is an estimate of a parameter obtained by a sample. So it's probably a statistic, huh?
So I feel like the 20 random and their mean scores was 112. I feel like that is a statistic.
Okay.
I don't know.
Well,
I guess 100 could be. I would say, yeah, then I would say that the 100 is the parameter.
Yeah, I'm thinking 100 the parameter and 112 the statistic.
Yeah.
Yeah. So we do mark both of those? We do
Yeah.
that?
Yeah, it says which of the following statements are true.
Okay. Read the S's on the ends of words. That's really
Yeah,
good.
it's important.
Okay. Rotham City has 4 distinct neighborhoods. The poverty values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has a very low poverty values, and another has extremely high poverty values. Property tax. Oh my gosh, has it been property and I've been saying poverty this whole time? Oh my gosh, I'm sorry. Okay, so property, my bad. Property taxes are usually roughly proportional to property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? Ah,
See, this is where I need my notes. I know
Well,
it's not SRS. It's not that one.
so I put a stratified sample because it divides them into groups and then an SRS is taken. And the neighborhoods are kind of like groups, is where my thought process went.
I
But
think
I don't actually understand why it couldn't have been any of those options.
yeah. Well, and they're just asking which one is the best
The best.
that we should use.
No idea.
I know. I like this stratified idea because you're right. It puts them in groups and then
They're already kind of grouped to begin with.
yeah.
I think
Anybody
that's.
else have any other thoughts?
I think you're right that you pick out the different groups and then you do the random sampling within each group.
Mm-hmm.
If I remember my stratified.
Yeah.
And systematic is randomly choosing one
Every, like,
and going by
4,000
every
or
other
whatever.
9 or every
Right.
other 40 or something like that.
Right.
Which I guess could work, but and then simple random sample is like
I can't remember if this is true. In the reading for this section, didn't it say that the SRS gave the best information overall, just because it was more I don't even have words today. It was more random. So it was like an unbiased sample.
true.
I can't remember.
Let's see. Systematic is select every quote K individual and then choose the first person with a random start. Those are my notes.
You know, I think we should go with stratified sample. I'm feeling pretty good about that.
I do too. Yep.
Y'all feel good about it? I feel good about it.
All right. I'm sorry if I'm wrong, guys. But I'm going through the other ones and I'm like, stratified makes the most sense because we want to see which groups
within each
respond to the
neighborhood.
property tax increase. So that makes more sense to me. Okay. When designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is this? Or is implemented?
Cluster.
Yes.
There it is. Maybe scroll. There we go.
Okay. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? Simple random.
SRS.
Yeah.
SRS.
Yep.
A special interest group is conducting a survey regarding wolves in Yellowstone National Park. Actually, have you heard about this? This is a real story.
No.
Yeah. It actually like changed the whole ecosystem to a healthier ecosystem. Anyway, it was really cool. To adequately gauge opinions on both sides of political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
Stratified.
That's a stratified, yeah.
Mm-hmm.
I wasn't seeing it there for a second. I was like, what happened? I don't know what's happening. Where'd it go? Okay, and then we need to get this Crossroad purchases spreadsheet up here.
Yes.
Okay. It looks like... All right, if this is going to be one of those like doctor, the doctor like hospital thing that we did, I'm not very good at that because like I could not figure out how to do it on Excel.
So the teacher gave us these spreadsheets. It's called a quantitative description statistic.
Uh-huh.
And it has all of the formulas in it already.
Oh.
So for this one, we need the mean. So what I did was I copied the formula from that spreadsheet. It's from like lesson 1 or 2. I copied the mean formula and I put it in the spreadsheet for the Crossroads one, and I got 4.771.
For the mean of that?
For the mean, yeah.
Okay, hold on. I'm just almost behind you.
So I think that the formula is equals, and then you type out the word average, and then you do column B. So it's B, semicolon B.
Gotcha. And is it just like you do the whole amount column?
Yes, that's what I did. I did B2 all the way to 89 or whatever it is.
Okay. And then down here, whoops. Oh, whoops. I'm sorry, I didn't mean to do that. I'm sorry. All right, let me try to do it. Oh my gosh. Goodness gracious.
So it's equals, average, then open parentheses.
B, and then colon B, close parentheses.
Colon. And then enter, right?
Mm-hmm.
It didn't work for me. I must have done something wrong. Anyway, so I'm just writing down the formula for this.
Mean. All right, what did you say you got?
I got 4.771.
All right, that is what I...
771.
All right. Did everybody get
and then, so for the standard deviation, I did the same thing. I took the formula from the other spreadsheet.
Uh-huh.
And I got 1.912. And the formula for that, if you guys want it, is equals STDEV, and then open parentheses, B, semicolon, B, close parentheses. No. Hey.
Could you do the formula for that one more time? Equals STD as in dog.
D as in dog, E as in Eddie, V as in vampire or Victor. Open parentheses, B, colon, B, and then close parentheses. Got it. Fill it up here. And I got 1.912.
Is that the question 9?
Yeah.
Sorry, 9.2?
1.912.
Oh, 1.192. Okay.
Okay, I've gotten 2 different answers. Sorry about my ears. 1.912, correct?
Yes.
Got it. All right.
Oh, I missed the number. Okay.
All right, who created a histogram?
Not me. How do you do
I
that?
just put it into that other spreadsheet. You guys should save that thing because I think we might need it for the exam.
For the exam, okay.
You
So,
said that was in
on that-
lesson 1? Lesson 2?
Dave,
For the
where you got that spreadsheet
Yes, it's the correlate. It's from the histogram lesson.
Which one was the histogram lesson?
that was like lesson 1 or lesson 2.
I think no.
Here.
It's lesson 3.
Oh,
Okay.
Lesson 3. So it should be in there. I can email it to you guys if you don't have it or can't find it. But
Great.
I guess I didn't create one.
ugh, push the button.
okay.
So we're on question 10, creating a histogram.
Yeah.
Yeah.
It's been a long time, a total of 3 weeks, maybe. How do you create a histogram?
I don't actually know how to tell you how to do it. I
Oh,
just use the
okay.
formula from the other spreadsheet and inputted the data there.
Okay, let's see.
Stella.
Oh, okay. I've got it. I found it. How about that?
My computer's attempting to pull something up.
Oh, I think I'm doing this wrong. Whoops. Oh, shoot, my bad. Okay, let's see.
Okay, once you paste it into the left column, then do you press enter?
Yes. And you should see your histogram change.
Paste your data in the column on the left, with or without a title. Determine the number of bins you want in your histogram in cell D3. Nothing happened. Absolutely nothing happened.
Oh,
You know what? If I get one wrong, at least I know where to go. I found it on my desktop. I'm happy.
there you go.
So this looks like it's just a normal bell-shaped histogram.
Yeah, question doesn't even ask you about it. So
Oh,
it just wants to know whether or not you created one.
well, I did now. Okay.
I had trouble with these ones. I don't know if they're correct.
With like the question 11.
Yeah, 11 and 12.
Okay, let me read it. I think this was another one on one of the other quizzes. This is a familiar question. Oh, this is finding the deviations. Let's see. I have notes on this, guys.
Ooh.
I just have to find where I put them. But I totally have them. Is this it? Here we go. This is it. Okay. So, first things first. We have the representative temperature of the seals, right? And to get the mean, we take the temperature and subtract it from how many seals there are. So there are 4 seals, right?
Mm-hmm.
So on the first one, we take 37.91, subtract. Oh, wait, we have to find the mean first. My bad. Okay, so find the mean first. Hold on.
We have to add them up first and
Yeah,
then
so add them up first. 97.91 times plus, rather, is what I meant to say. $37.25 plus 38.98 plus 38.16 divided by 4 is 38.075.
Would you round that up to 0.1 or no? Or do we do that at the end, right?
Yeah, I think
Round it.
she sent out a notice or something. Don't round until the final answer.
I'm sure she did.
Okay, so 38.075 is our mean. Okay, so then we're going to take 37.91 minus the mean, which is 38.075. And find that answer, whatever it is.
0.165.
0.165 is what I got.
I got a negative 0.165.
Yeah, that's what I got.
I got
Yeah.
that as well.
Okay.
Which is correct.
Which would be
Yeah, so the deviation from the mean can be negative, but the squared deviation shouldn't be negative. Does that make sense?
Yeah.
Right.
Okay, so negative 0.165. All right, now we do that for the other ones. 37.25 minus 38.075 equals
negative 0.825.
825. Yep, negative 0.825. That's a point. And the last two, 38.98 minus 38.075.
Oh, did not do something right.
This one should be positive. Yep, 0.905.
Oh, I did not get that. All right.
Okay, so the last two should both be positive.
Mhm.
Okay, so I have 0.165 or negative 1.165, negative 0.825, 0.905, and then 0.085.
That's what I have.
Yay! Okay. So now we take that squared form. So we're going to take our mean numbers, okay? And then write them in squared form. So we take negative 0.165 and square it. So negative 0.165 squared is 0.0272. 0.0272. Let me take our next one. 0.825 squared. Oh, that's a negative. Make sure it's a negative, Kira. Make sure it's a negative. Jeez.
Zero 0.681.
I have 0.68. Yeah, but I thought she said not to round until our final answer.
Like at all? No. Okay. So we'll put 0.6.
Yeah. .806. Okay. And then 0.905 squared. Oops. Is 0.8190. And then the last one, 0.085 squared. Is 0.0072. Okay.
So for question 11, we had a negative 0.165.
Yeah.
And then 12, which is the squared part for the second row, is 0.681.
Yeah.
Okay.
For 13, I got none of those, but don't.
That's what I remember this one. I said none too.
Okay.
Yeah, that's what I have down on my homework.
Okay.
What do you think, Kira?
Oh, sorry. I was reading B still. I was on 12 still. Sorry. I was just a little bit behind you guys.
No problem.
6.68. Oh, so I guess for those final answers, for 12 at least, that can be a 1.
12?
Yeah.
I had
Yeah.
a 0.681.
Yeah.
Yeah. That's what I got.
All right, and then 13, what is What quantity is equal to the sum of the numbers in squared division column? It should just be the sum because the variance is the sum minus or over n minus 1. So not even quite the variance. Let's see. Okay. So it is none. Good deal. What is the standard deviation of these temperatures?
I didn't
So
figure that one out
What's the
yet.
next step on this? I've forgotten.
So the standard deviation, we have to take the variance. So we have the sum of the numbers that we squared together. So add those all up.
Okay.
Let's see. 16. 16.
After we add this and get the sum, do we do the square root?
No. So you take the sum, right? So we have to do the variance. So it's the sum divided by n minus 1. Okay, so n minus 1,
Would be 3.
yes.
So divide
Yes.
that, the sum by 3.
1, 2, 3, 4, 5. Yeah, it would be 3, yeah. So take the sum, divide it by 3, and then you get your answer.
Okay.
Okay, and then our standard deviation is that answer square rooted, which should be like it should be a positive number.
Okay. Let's see.
Divided by. Okay, so I got the square root of 0.5112. Did anybody else get that?
No. I got 8.6895.
8.6895.
Yeah. So I'm off someplace.
Okay, let's try this again.
I think I missed a decimal point in there, so I'm gonna start.
0.0272 plus 0.6806 plus 0.8190 plus 0.0072. 1.534. Right? And then we take that and divide it by 3. You get 0.55, or not 55, 0.5113. And then that is, we square root that to get 0.264. Yeah, that's I got the same.
Yeah, I did the decimal in the wrong spot. That blew it. So what was the answer again?
So the final answer of the squared, let's see,
Square root.
of the standard deviation is going to be 0.261. Does everybody understand how we got that?
I do not. Where did you get the 3 from?
Yeah, that's totally fine. Let me, you know what? I think it's a good idea if I put this. Whoops. Okay. All right, I'm going to share my screen, okay?
Okay.
And show you, because this is, I think it's important that you guys see how we do this.
Are we still on number 14? Sorry, I had to go to the bathroom real quick.
Yeah, we are. We're finding the standard deviation. Yeah, you're totally fine. I'm just explaining it so everybody understands how we do that. Okay. So let me share my screen. Okay. Yes, share screen. Awesome. Okay. So does everybody see my Excel right here?
Yes.
Okay. So I have let me pull up my data again of the, there we go. And actually I'm going to make that small and bring it over some so I can type at the same time. Okay. Okay. All right. So here in my data, right here, we have 4 seals, right? So we're just going to go 1, 2, 3, 4 right here. So our first seal, actually, I'll just do 1, 2, 3, 4. I'm not going to write their names because that's a lot of that I don't want to do. Okay. So now we have the sample size and our mean. Let's see. I am actually at the wrong one. I'm glad I looked at that. It's actually this information that I need.
I'm about to say, I'm like, what are you looking at?
Yeah, nope, that was my bad. I was like, what the heck am I looking at? Okay, no, that was totally my bad. Okay, so we have our first seal has a representative temperature of 37, right? Okay. Our second seal has a temperature of 37.25, right? Our third seal is 8.98. And our fourth seal is 38.16. Now we take all of these numbers, right? Whoops. All of these numbers, and then we add them up, get the mean, okay? So because I don't know how to work Excel and I'm really bad at it, I'm just going to take my calculator here. 37.91 plus 7.25 plus 38.98 plus 38.17. Okay, that's 152. Then we divide by 4 to get 38.075. Does that make sense?
Mm-hmm.
Yes.
Okay. So right here, I'm actually going to put it in this column. We have 38.075 for our mean. Okay. So over here, and I'll put mean deviation, actually, is what it is. How come it never does the wrap text like I want it to? Yeah, totally. Okay, whatever. Anyway, so our deviation from the mean. Now, this, we take the equation, we take our 37, okay, for our first seal. So we go 37.91, subtract by our mean that we got, okay? So 38.16. And then we do that for all of them. So we have 37.25 minus 38.16. Same with this one, 38.98 minus.
Do you mean 38.075?
Oh, I do. I'm sorry. I was looking at my fourth one. My bad. Thanks for catching me. I would be a horrible teacher, guys. I'd make mistakes all the time, and my students would be like, "What the heck are you saying?"
I would follow you, so you're okay.
We're good. We're good.
I'd have to know what I was doing in order to question you. So.
Yeah, totally. Okay. So, and then the last one, which is the one that I was looking at, which I got confused. Okay, so 16 point or minus 38.075. Okay. So now we go over here, and this is our this is the squared deviation from the mean. Okay, so now we have all of these, right? And we need to find our answers, obviously, to what these are. So 37.91 minus 38.075 is negative 0.165. This one is negative 0.825. And our third one is 0.905. Our fourth one, 0.8 or 0.855. Okay. So that's the answer to our mean that we got over here. Okay. And then we take these numbers and we square them. Does that make sense?
Yes, thank you.
Okay.
I
You're
appreciate
welcome. Okay, so we take out my calculator again.
it. Hi, Lindsay.
Negative 0.165 squared is 0.027. Okay, so we put 0.0272. And this one squared is 0.6806. And this one is 0.8190. And this one is 0.0072. Okay. Does that make sense? Does everybody know how we put these answers?
Yeah, thanks.
Okay. Now we add these up to 1.5336. Let me just make sure. 0. Plus 0.6 plus 0.9 plus 0.00. Or 4. It rounded to 4. But it's really like 336. But that's fine. Okay, so we'll round it to 4. Okay. Now, this is where everybody kind of got confused. We take the sum of this number, okay, and we take the variance, or we take it to get. Now, there are 4 seals, and to get the variance, we have to take our sum divided by n minus 1. Now, n stands for number or our sample size. Stands for. And in statistics, I guess it will always stand for that. Now, because we have 4 seals, minus 1 of 4 seals equals 3. Okay. And then, so then we're going to have 1.5 or 1.534 over 3. Okay. And that's going to give us, not going to give us 3. That will give us let's see, divide by 3. Where's my divide sign? 0.5113. Okay, is everybody good there? I can't hear you anymore, Donna.
Yes, we're all good.
Okay.
So did you square that or square root it?
I haven't square rooted it yet. I've just divided it by n minus 1.
Okay, gotcha.
Okay. Now that is our variance. N minus 1 over our sum, or our sum over n minus 1 is our variance. Okay. So to get the standard deviation, we divide that to get this 0.5113, and then we square that to get 0.0513, and then yes, you square root this to get 0.0022.
Is it 0.05 or 0.51?
Oh, my bad. Thank you. 113. Square root that. There we go. 0.264. And it would stay in line. That's the final number that you round to, because it's higher than 5.
So this is our standard deviation for number 14.
This is the standard deviation for number 14. Does everybody understand how I got that?
Yes.
Excellent.
You just square it at the end.
Yes, you square it at the end. Yes.
What answer did you get? Sorry, I wasn't paying.
For what?
For 14, what was the answer that you got?
0.261.
Okay, that's not correct.
For the standard deviation?
Right, that's not correct. I double checked my answer on Excel. I didn't get that.
What did you get?
I got 0.715.
0.715.
I'm sorry, I wasn't paying attention to the last part of your the equation that you were doing because you were going along like fine, and I was agreeing with everything you said. So I started looking at some other stuff, and I missed the last part of your explanation. But I didn't get that when I did it earlier today.
Is it supposed to be
5?
Is it
Well, I
it
can't
supposed
see
to
your
be is
your
it supposed to be
worksheet.
squared, or is it supposed to be the square root of? Which one?
This is the answer of the variance that I got. The variance is the sum. So our sum right here over n, which is 3. Okay.
Okay, I can't see that because it keeps going up and then turning back off. Is there a way to get that up on the screen? Like permanently?
Did I stop sharing? Is it not sharing still?
No, it's sharing, but it keeps popping to Donna's face every 2 seconds and it comes back
Click
off.
on Kyra's screen.
Donna,
It'll
don't
stay
you-
on her.
Okay.
Okay.
All right. Everybody click on my face in the
In
bottom.
the bottom.
Donna, can
Donna,
you?
can you?
Okay.
Okay.
Everybody
Everybody
click on
click on
like my
like
square,
my square,
and it should
and it should
stay
stay
on
on
my
my
face
face.
and what I'm
And what
sharing.
I'm sharing.
Okay.
Okay.
So
So
this is
this
where
is where
we have our.
we have our force.
This is
This
their
is their
represented
representative
in Celsius. This is our deviation from the mean. Our mean is 38.75. It says 0.075 up here. Okay. And then we subtract from all of them from 38.75 to get these answers, negative 0.165, negative 0.825, positive 0.905, positive 0.085. And then we square those to get the squared deviation from the mean to get, so the square root of negative 0.165, 0.0272, square root of negative 0.825 is 0.6806, square root of positive 0.905, 0.819, and the square root of 0.085 is 0.0072. And we sum those up to get the sum up here of 1.534. And our variance is the sum over n minus 1. N minus 1 is our sample size minus 1, so that's 3. So we have our sample size, or our variance rather, over our sample size minus 1, which is 3. And then we equal that, or we divide by that to get 0.5113. And then we have to square root this to get our standard deviation, which is how I got the square root of 5113 squared is 0.261.
Okay, you don't square it. You take the square root. And if you do 5 point whatever you got, 0.5513 or whatever you put there, if you get the square root of that, you will get 0.717 probably.
Let's see. Oh my gosh, you're right. Hold on. 0. And you got 0.0715.
Yes. Yes.
Okay, that makes more sense. And actually, I do have that on my paper. Look, I'll even show y'all. I have it freaking right here. on my note, and I was just like, square root, it's squared. That means square it. No, that's totally wrong. So I did everything right up until the very end. This is why, guys, I'm never going to be a teacher ever. Because I screw up at the very end. Okay, so like I even have, let's see. I even have it right here on my paper. Right here. It's like, no, you're supposed to square root it, not anything else. So that was my bad. So you're totally right. It's 0.715. My bad.
But you did a totally spectacular job. Like, so good. I was like, oh, she's got this. I'm going to go check some other stuff.
Okay, so sorry. Does everybody understand where I went wrong?
But that was excellent. I wrote that down. To find standard deviation. I have my steps all in a line. Very
Good.
nice.
I have my little samples going here.
Awesome, good. And you're not supposed to square it. You're supposed to find the square root. That is my bad. That was totally my bad.
I followed you up until that point, so we're
Awesome.
good.
Okay, Lindsay, thank goodness you're here. This is why. Oh my gosh. Goodness gracious. Okay, so for the answer for 14 is 0.715.
Okay.
All righty. And
Are
I
we
think
recording
somebody,
yet? Or are we just, I'm
Oh,
going to record.
Oh, we're recording right now.
Oh, okay.
Yeah.
I
All
think
right.
somebody already answered 15. You can't have a standard deviation that's negative.
That's true. Good job.
There's false.
All right. Which location resulted in the most consistent temperature measurements from one seal to another? In the most consistent.
Wouldn't that mean that the standard deviation was very small?
Yes.
So the extradural.
Yeah,
Yes.
so that would be the extradural. Say
I hate box plots.
All right, the numbers of hours students spent studying for an exam were recorded. The data are represented by the box plot below.
Do you remember how to get there?
I know it is.
Okay, so our third quartile, is that where we decided was the median, or is that our second quartile
What?
in the box plot?
The heavy
The
dark
box
line
plot
is-
shows the lowest number. It shows the first quartile, the median, the third quartile, and the highest number. So
Okay,
it's basically a graphical representation of the five, whatever they were. Forgot what they called them.
Yeah,
Five things.
I know what you're talking about. Okay, so our third quartile is this. Is
Five
the,
number summary.
yeah, 5-number summary. Yeah, there you go. So is our third quartile the 75%?
Yes.
Yes.
Okay.
So on here, it looks like 2 would be the lowest number.
Yes.
And then where it has the bottom of the box, so at 4,
Yes.
that's going to be the first quartile, so 25%.
Yes.
And then 6 would be the median, or 50%, or second quartile,
And
whatever
then
you want to call it.
the top of the box plot would be the 75th% or the third quartile.
So
Correct.
that
And then
means-
that number way over there on 12, above 12 would be the highest number.
yeah.
Okay.
So
Okay.
the 75 percentile would be 8 hours. You just put 8.
Yes.
Yes, so
Yes.
we just put 8. Okay. What percentage?
Wait, what is 8 hours? Like, what is that the answer to?
Oh,
It's the
number
answer to
17.
question 17.
17.
My 17 doesn't ask that. My 17 says, in your own words, without using any symbols, explain what the standard deviation is.
Whoa.
Yeah,
Are you on the test or on the preparation sheet?
Are you guys taking the quiz right now?
Yes.
Yeah.
We are.
Oh, was I like really late or something? I thought we were meeting at 9 or 8 Central or whatever, or 8 Mountain.
We started at 6, so 7 your time.
8 o'clock Mountain Time, 9.
8 o'clock Texan time.
Oh, okay. Sorry, guys. I got the time all messed up on that. Then let me get in the quiz and I'll catch up because I wrote all my answers down. So I'll just catch up to you guys.
There you go.
Okay. So the answer for 17 is 8.
There
That
you
is
go.
correct, because that is the third quartile. Okay, and then for 18, it says, what percentage of data lies between 4 hours and 8 hours? List the numbers as a percent, not as a decimal, and don't include the percent sign. Example, if the answer is 66, then only put 66, not 0.66. Okay, so between 4 and 8 is, let's see, that's from the 25th to the 75th.
That'd be 50.
That'd be 50.
That was easy. Okay.
Yep. Not hard. Which is nice.
I say that until I'm doing it on my own, not looking at it. I'm like, I don't know what I'm looking at.
Okay. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that a nitrate concentration in the city's drinking water supply is between 1.57 or 9, my bad, 1.59 and 2.52 parts per million. And values outside of this range are unusual. We will assume that our mean minus 2 standard deviation equals 1.59 parts per million, and our mean plus standard deviation of 2 equals 2.52 parts per million. It is reasonable to assume the measured nitrate concentration is normally distributed. All right.
Didn't we answer this question?
We did.
What am I missing here?
Estimate the mean of the measured nitrate concentration in the Rexburg drinking water. Okay. So to get the mean from just the standard deviation and the parts per million.
Oh my gosh, I'm having deja vu. I answered this. When did we
We did.
answer this?
Yeah, it's 2.055. We did that one at the beginning.
We did this one at the beginning?
Why did we do this at the beginning? What am I
I don't know. It's
missing?
2.52 plus 1.59 equals 4.11 divided by 2.
I remember doing it. I just can't remember
I have it
why.
written down, so I'm pretty sure this is the one we worked on.
I have no
Well, I
idea.
know Emily and I were talking about it at the very beginning.
We did this at the beginning of this quiz?
No. Just at
We
the
were just talking while we were waiting for you, but I
Yeah.
can't remember why we were talking about it. Anyway, we can do the math real quick so everyone's on the same page.
Yeah,
Yeah.
that's a good idea. That was so funny. I was like, I've never seen this before, or I just don't remember it. Okay. Does everybody know how to get the mean from the standard deviation?
No,
And
I forgot it. Go ahead.
Okay, hold on. I have to find my notes for it to make sure I'm explaining it right. Because I tend to do that. I tend to just get ahead of myself. All right, yeah, let's see. Mean. Sorry, I'm just looking, guys. My bad.
Did Emily, you seem to have a formula for it. How did you get your answer?
I just added the 2.52 and the 1.59 and then divided that by.
Oh, you divide it by the standard deviation. Oh, that's totally right.
But where do you get the standard deviation out of that problem?
So the standard deviation is sigma. This sigma sign. All right, hold on. I'll share again. Okay. So the standard deviation is this sigma sign right here. Okay. This is sigma, and this is mu. Mu is equal to mean, right? The standard deviation is equal to sigma. Okay. So when you see a 2 or whatever number next to a sigma sign, that's the standard deviation we're working with.
Okay.
Okay. So what Emily did, which is totally correct, is she took the 1 point, whatever it says. Let's see, where'd my thing go?
0.59.
1.59 minus the 2.252 and put it over. This line right here is going to be over, okay? Like this, I'll do it in a second. Okay, and then over the standard deviation of 2. 2 is our standard deviation. So, man, I wish I could make this darker, but you see this line right here? That's going to be our division line for this. Okay, and then we divide that. So to get the answer of, Emily, what did you say you got? What even?
Oh, like the total? I got the end result. I got 2.055.
2.055. Okay, that seems... Okay, so we take 1.59 minus 2.25 divided by 2. Hold on, what did I do? Give me this.
I added. I put 2.52 plus 1.59.
But aren't we supposed to subtract?
I don't know.
Wait, is this for the mean?
We're supposed to add it and then divide it. No.
Let's see. I actually can't remember if you're supposed to subtract it or add it.
To find the mean, wouldn't you add it and then divide? No. Did we?
Well, don't you subtract the 159 from the 2.52?
But that's to get a z-score.
Oh, never mind. Just a thought.
Which is why I'm confused.
Okay,
that
what
was
number are you
totally
guys on?
z-score. We're on
19.
Yeah.
No,
Okay.
no, 19. We're on Oh wait, no, it is 19. Never mind.
Yeah, we're
Okay,
on 19.
Okay, I got 2.055.
And did you add it?
So what they're showing us is that 1.59 is 2 standard deviations away, and 2.52 is 2 standard deviations the other way.
Yes.
So what I did was I took 2.52 and I subtracted 1.59 from that and then divided that by 2.
Okay, so we had it right, but
that just gives you what the standard deviation is. Wait, is that what it's asking, is what the standard deviation is?
No, 19
Let's
is asking for the mean.
Oh,
20
it's
is
asking what the mean is. Okay. So yeah, so then I took that answer, the 2.52 minus 1.59. I divided it by 2, and then
Yes.
I added that, what I got back to 1.59.
Okay.
Yeah, I got the same thing, but I did mine the old school way, I guess. I don't know.
Oh, the other thing you can do is just average them, probably.
Yeah, that's what I did. I
Like
just added
I do.
them,
Oh, what did I
divided
do?
them by 2.
Yeah.
So the answer is 2.055.
Yes.
Okay.
$2.055. Okay. Okay, so now we have the standard deviation of the measured nitrate concentration.
Right. I got 0.232. Well, actually, after you round, I got 0.233.
How did you get that?
Okay, so we know how much, we know what the mean is now, which would be like, I don't know, like the middle. And then we know how much 2 standard deviations is away. So all you have to do is figure out the number that's going to be between the mean and, like, exactly between the mean and the, like, either one, either the 1.59 or the 2.52. So basically I just averaged those. I took 1.59 and 2.055 to find out what the standard deviation was. Wait, hold
And
on.
you did that with the...
Hold on, let me look at the answers are not exactly the same. They don't line up exactly the same. So let me go back and make sure I'm not shouting out some weird wrong number. Okay, let me see what I got here. What question does that match in the homework? What is this?
The standard deviation of nitrate concentration.
So number 23.
Is what that matches.
Oh, no, that's not true. No, it doesn't match 23. What does it match? Estimate the standard deviation. Okay, so that's 21. Yeah, I got 0.2325.
0.2. I'm hearing a lot of 3s. 0.2.
Yeah, well, I'm sorry. Let me adjust for the rounding. I got 0.233.
Okay. Would you mind just going over the formula for that one more time?
Okay, so at this point we've figured out what the mean is, and for the mean we got 2.055. And then we know how far away 2 standard deviations is. 2 standard deviations away is 1.59 or 2.52 if you look at the other side. So I just found out what the distance was between those 2 numbers and divided it by 2, because it's going to be exactly halfway in between those 2 numbers.
Are you using the applet?
Huh?
Did you use
I'm just using, like, math. Like, I'm not using an applet.
Because I guess you could also find it with the if you have two standard deviations, you can find it with the 68, 95, 97.7, or 99.7 rule.
I think in particular, this group of questions, when it uses the word estimate, I think the simple math is what they're kind of looking for.
Yeah, they don't want you to calculate it with the tools. They want you to like kind of use your thought process to figure it out.
Which is a very bad idea, but I'm just saying that. Okay. Just, but that's all right.
Okay.
So what are we on now?
21.
I'm in my meeting. Are we on 21?
Yeah.
Yeah.
Oh, okay. So
Sorry,
we just kind of,
my notes.
so we've already figured out what two standard deviations away are. Actually, I think they give it to you in the question, right?
2.52.
1.
Yeah, and 1.59. And so we know with the 68, 95, 99.7 rule that 68% of the data is going to lie between two standard deviations away from the norm, right?
Yes.
Wouldn't it be the first deviation?
Yes, that's 68%.
Yeah, but it wouldn't be it would be more like 2.23.
Let me look.
And it does say approximate, but because C, isn't that the 95 percentile?
Hold on. I'm double checking. Okay, so you would just take one, it gave us what two standard deviations away was, is what I'm saying. And so we already have that information. Two standard deviations away is 0.159 and 2.52. And then we figured out how much distance one standard deviation away is. So we just would subtract that from both ends, from 1.59 and 2.52, to tell us what one standard deviation is away, because all that data, 68%, is going to be between one standard deviation to the left and one standard deviation to the right.
Okay.
So I don't know why I just wrote down that, but I didn't actually calculate that out. So let me do it. So 2.52 minus 2. So it's going to be between 875 and 59 plus 0.2325. So it's going to be between 1.822 and 2.288.
Yep. And that's answer D.
There we go.
And that's what I got on my Excel sheet too.
Oh, it's multiple choice. Didn't notice that.
It's okay. We still had to do the. We still had to do it. We still had to figure out which one it
Right.
was. That's funny. Because a lot of the time it's not multiple choice. I've noticed in these quizzes.
I know, but if I had paid attention to that, I would have only had to figure out one end.
Oh, that's funny.
Oh, wow.
Yeah. All right. The admissions committees for most Masters of Business Administration programs require the Graduate Management Administration test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 5. Sorry, I'm writing this down. 542.3. That's a 5. And a standard deviation from the score, let's see, is 120.54. Okay. The GMAT score required for admission to MACC's program in the School of Accountancy at BYU is 500. But it is rare for students with scores less than 600 to be admitted. Holy cow. Okay. Okay. What is the probability that the randomly selected student will score above 542.3 on the GMAT? Okay. And this is the stuff that we've just recently been working on.
This one's just going to be like 0.5.
Yeah,
0.
because it's like
It's because it's saying what is the probability that the student will score above 5. What they gave, the number they gave is the same as the mean.
Yeah.
So that means exactly in the middle. So there'd be a 50% chance.
Just a question. If wasn't there a rule about the probability if it's 0, then it's equal. In other words, it comes in the middle, like you just said, 50% or something, or that's 1 or something.
So underneath the area of the distribution arch thing, whatever we call it, the applet, it has to be equal to 0 or 1. If it's equal to, it can't be less
Then 0.
It can't be negative than 0. If it equals to 0, then yeah, it's going to be like right in the middle.
Right.
Okay.
So in this case, you would, if you were to calculate it out, in this case, you would do 542.3 minus 542.3, which would give you 0, which is not divisible. So it would, your answer would just be 0, which means it'd be, your z-score would be 0. Z-score of 0 is like right smack in the middle. So
It's a 50% chance.
mm-hmm.
When I did that problem, I thought this looks so wrong, but I'm glad it's right because I did it right. Okay.
And then 23. What is the probability that a randomly selected student will score below 600 on the GMAT?
I got 0.684.
Yeah, hold on. I'm doing the math real quick.
Just while you're doing that, for question 22, was that in decimal point or percentage?
Actually, in decimal point.
Okay.
Yeah. 1, 4, 7. Okay, did you say 0.64? Because that's what I got.
I got 0.684.
Oh, I got 0.638. What did I do wrong? Did I put that in wrong? Oh, yep, I did. Hold on. Let me fix that. I still have 0.63. What am I doing? So I take
I
542.3.
might have put it in wrong. Hold on, let me redo it.
Okay. Because I was like 542.3 minus 600 over the standard deviation
Oh,
of 120.
That's what you're doing wrong. You always put your X value first.
Oh,
You've
my
got 'em
600
switched.
first?
Yep.
Okay. Let's try it that way then. 600 minus. Oh, Kira. Oh my gosh. Okay, let's try that again. Okay.
I got a 0.316 for this. Does that sound right?
It isn't what I got.
It's
Well,
not what I got either. Hold
Okay,
on,
then. Then we're not gonna.
Okay. 600 subtracted by 542.3 divided by 120.54. 0.047. Where's my apple?
So what I did was I did our X value 600
Yeah.
minus the mean 542.3
Yes.
divided by the standard deviation of 120.54.
Yeah.
And I got 0.478. What did I
Yes.
get? 0.4786792, blah, 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 blah. So I took that out to 4 decimals because I think that's about how many you can get on the applet. Because this equals our z-score. So
Right.
0.4787 is what I would put into the probability applet. 0.4787. And then I hit
I'm still
enter.
getting 0.63.
Right. And
And
then
that's-
now you have to shade the area to the right only.
Oh, yeah, I wasn't doing that. Why
Oh,
is
and
this
it is,
freezing?
you know what? It is 31.6. This is like so confusing when I
Oh, I feel even better. Oh, my.
That's the answer
Oh,
that I
it
have
is.
on the next one down.
Okay. Now that this is good that we do this all together, guys.
Yeah.
It's very- it's too bad we can't do the exam together.
Okay, so 0.316.
Yeah.
That's funny.
For number 23, right?
Yeah, for
Yes.
number 23. Yeah. Oh, that is so funny. I was like, I keep getting 0.63. I get getting 0.63.
Wait, I thought we were on 24.
Oh, we are now.
Well, that was our, wait, the score above? would
Oh,
be
yeah. The score
24.
above is 0.316. Okay,
Yeah,
so if
that's
you're going to do
24.
below, then you just shade the area to the left of that. So I was right. It is 0.684.
0.684 for the first one. So number 3 is actually 0.684. Oh my
Yeah.
gosh, why is this being so dumb?
Well,
My
and
app is
the other answer that you had, 0.316, is
Ah,
to 24 then, because that's above.
Right. Above is going to be 31.6% or 0.316. Below is going to be 0.684.
Got it.
Below is 0.684.
3.316 is for below.
Okay, 0.316. And then above,
No, the above is 0.316. The below is 684. Sorry.
Okay.
0.684.
thing froze anyway. So
When we round that
I was like,
we round that up to 32, right? 0.32. Or do we need
Yeah,
to keep?
No, I think we're supposed to carry out to 3 decimal places, right?
Yes.
It doesn't say anything. Does it say on there? Hold on. I don't know.
I think sporadically through the exam, it'll say that. But generally, I think wasn't Sister Withers say, unless otherwise, we just do that on a normal basis.
Right. Okay. So for 25, I got 387.768.
That's what I got.
Awesome.
What
What'd you
was
get?
387.768.
And that's for the 10th percent.
Correct.
Well, that score is kind of sad, isn't it?
Mm-hmm.
That's a kind of sad score. But that makes sense for the 10th percentile. That makes sense. All right, and then which one is the 90th?
The 90th, I got 693.832.
693. 92?
0.832.
Oh, 0.832.
Mm-hmm.
Okay.
Could you do that? Because I was one number off. One more time.
693.832.
Okay. I had to have done a math thing. We're good. I get it. I know how to do it. We're okay.
All right. Find the first quartile of the distribution of GMAT scores. So the 25%.
Now, this is one of the ones, these next two, I did not get. I didn't figure out how to do that.
Okay, Donna. Well, you would basically do it the exact same way as you did the 2 previous ones, except for you would put in 0.25 and 0.75.
Oh, that's such an easy fix. Thank you. All right. Thank you.
You're welcome.
May all life problems be like that. Okay. I'm good.
So for the first quartile, I got 461.056.
451.7.
I got 461.056.
461.
My bad.
056.
056. My bad. Okay.
And
then-
for the third quartile,
35th.
I can't read my handwriting. Hold on. Let me bring it closer. 623.544.
Wow, that's a really good score.
One more time.
623.544.
Okay. Consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all such samples?
It's still going to be the same mean of 542.3.
Even though we
Yeah.
have 15.
Yeah, the mean always stays the same.
So it's still going to be 52423.3.
542.3. 3. But the standard deviation is the one that's going to be different.
Because you put 120.54
Divided by, yeah.
Okay.
What is the sample size? 15 divided by the square
15.
root of 15.
Yeah. So that, I gotta get my calculator out again. Do, 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 do. Oh, whoops. Oh my gosh. Okay. And that I have 1.85.
That's not what I got.
Seriously?
Yeah.
For the standard deviation?
Yeah, and I maybe
No,
got
that's what I just got for the 600 minus 5 for 2.3 over 120.54 divided by the square root of 15.
Yeah, and then we go to the next step to put it into the applet.
Yes, and I haven't put it into the applet yet.
Wait, which number are you guys doing? I'm doing number 30.
30,
I'm doing number 30. Yeah.
30.
Okay,
Yeah.
so it's just asking for the standard deviation of the distribution of the sample mean scores.
Yes.
So that's so I don't understand why you're putting stuff into the applet.
I'm not putting anything in the applet yet.
I did, so just ignore me. Go ahead.
Okay.
So the z-score, that's all we're working for then on this one.
No, we're looking for a standard deviation.
Okay, so I lost you after the z-score.
Okay, let me just double check. I did. I'm trying to figure out where I wrote this down at so I could see what I did. Yeah. Okay, what is this in? There's a mean distribution. Hold on, I'm trying to go back up to the problem.
Okay, so this is
There we go.
just our standard deviation. Here, I'm going to show, is it this one that we're looking for? The sigma x equals sigma over the square root of the number of the population?
Yes.
Okay, so I did it wrong.
Wait a minute. Show me your paper. Show me your thing again.
Okay, so this right here is the equation. Sigma x equals sigma over the square root of the number or our sample size. And
Yes.
that would be the standard deviation of the size of the mean, right? Okay. So I did that wrong. So I'm going to do this again. So we take our mean, which is 542.3.
I guess I didn't even write this one down because I just did it.
Okay, so go ahead. Step by step is good.
What is the standard deviation of the distribution of sample mean score? Okay, so we take our sample mean. Do you want me to show you again on
Yeah.
my
Okay, great.
Excel?
Sample mean of 542.3 divided by
The square root of 15. And that we get. All right, did you get 140?
Hold on.
What, how,
Hold on just a second.
what's the formula again?
It's going to be sigma x. So that's our. Oh, hold on. I'm overthinking this. Sorry. Okay, so yeah, standard deviation. Okay, so it's sigma x equals sigma over the square root of our sample population. Yes. So sigma is equal to our standard deviation, or sorry, our mean, with our mean. Is that right? So just kidding. So no, it is our standard deviation. So we take our standard deviation, which is 120.54, and divide that by our population size, which is the square root of 15, because we have 15 randomly selected students, to get 31.123.
Which is what I got.
Which is what you got?
Yes.
Okay. I just had to figure out in my head what I was doing.
What'd you get? I'm sorry, it was 31.
0.123.
Wait,
Okay.
is that what I got for that?
I just had to figure out what I was doing.
Yes. Yes, I got 31.123 also.
Excellent. Okay. Good. Okay, and now we have the sample mean, which is different. That is just our it's the same. Our mean is the same, 54 or 542.3.
That's number 29. Right?
Yeah, and then the probability though.
Wait.
So we have to put it into the applet for 15.
Which one are you working on now?
31. 31.
Okay.
Because we have to find the probability of it.
Right. So yeah, this one you'll do the, what are they asking? 600? 600 minus the mean of 542.3. And then divide it by. Oops. Where did I should have wrote this one down. I don't have it.
Divide by 120.54, which is divided by the square root of 15. How does that?
Yes.
All right.
Wait a minute.
Okay.
Yes.
Okay.
So then
And
we put that into our normal probability applet.
And
Well,
I
before
got
the applet, I got 1.8538. Is that correct?
Yes, and
for
then
the Z-score. That's what I got for the Z-score also. Actually, I got 1.8539 because I rounded.
Okay. I'm not going to round till we get to the end.
Why is this not working? Why is this being so ridiculous? Oh my goodness. 1.853. Fine, I'll put in a 9 just because we will. We'll just, yeah. Okay. Okay, fine. Oh my gosh, I think I have to restart my page. It's getting so mad at me. All right, there we go. 1.8539. Okay. For that, I have the probability is 0.319 or 0.0319.
That's what I got.
Excellent. So that is about 3%.
Right.
Okay.
But we're going to round to the 3 decimals, so it would be 0.032.
Yes. Yes. Yep. Am I missing? What answer am I missing that I didn't save? Because that was 31. Did I skip a question?
Did you get the very first one?
Maybe not. Let me go check. Oh, I forgot to save answer 19. Okay.
So we all ready to submit?
I guess so.
Because we're not going to go back and go over them, right?
I submitted mine. I got 87%. I don't even care. I'm not going over it again.
That's not bad. 87's not bad. I would take that.
I'll take that on an exam. He's my best friend. All right.
Oh, I guess this says that under certain conditions, the standard deviation can be negative.
What the book specifically says it cannot be negative.
I know, which is why I'm super confused.
I think we're going to, I vote for the book.
I got it right, and I put false.
Yeah,
I put false.
I did too.
Oh, guys, I totally misread the question. Oh my gosh. Oh my gosh. I need to learn to read things at least twice through.
I have the same problem because you just expect it to say something, so I skim a lot and it gets me.
Yeah, totally. Okay, so I got 90. Dang it all. And I probably would have gotten that other one right if I had just read the stupid question through. Oh my gosh. I feel really stupid about that.
We're good.
You got this.
So we're going to,
Okay. Well, there you go.
All
wish
right.
everybody really good luck tomorrow or by Wednesday midnight. We have to get this all done.
Yeah, I'm planning to take mine tomorrow night. It's the only free time that I have. So
The exam is due Wednesday midnight?
it is.
Yes.
What?
Yeah.
That is totally unfair.
Yeah, tomorrow and Wednesday before midnight.
Yep.
I might just take it tonight. I don't have time to do it Tuesday or Wednesday.
Ouch.
Yeah.
Well, good luck to you.
Yes.
All
right, I'm
Good
gonna
luck to all of you.
Broadcasting.
I'm gonna need it.
Okay.